is to gather the value. So to collect all the values from the sensors or send oh, very good, very good. That somebody started recording. Who did it? Dan Dorian or?
No, it's me, sir.
Oh, okay, okay, very good. You did it because I want to share also this record with some of our probably next future colleagues. Okay, so as I said, the basic function of the edge computer is to collect the data or send data to sensors and actuators. Okay. The link between sensors and edge computer can be done in a lot of ways. But basically there are two, on wire or on radio. On wires, normally there are industrial protocols. The most, the well-known protocol is Modbus. Yeah, so Modbus, it's a wire protocol working on the so-called RS 485 standard. So RS 485, it's, let's call it the hardware protocol, yeah, and Modbus is a software protocol. But of course, the sensors and actuators can exchange data with the edge computer using other protocols like IO-Link, like Profibus, like Profinet, etc. And as I said, there are also wireless protocols. Speaking about wireless, of course, the well-known protocol is via Wi-Fi. Yeah, it's possible to connect via Wi-Fi, but also on there are possibilities that also to convert industrial wired protocols on radio using, let's say, converters, which can do this task. For instance, you can convert or send data on Modbus, but having two special devices who exchange the data through radio. Normally, this kind of radio transmissions are specific, so there is not a general standard, but they are specific to different manufacturers. For instance, Turk has this kind of devices. So they but think it like just replace the wires with such converters. So this is one sort of wireless. I told you about Wi-Fi, and when I speak on Wi-Fi, this means that it's using TCP IP or UDP, so this sort of protocols, of software protocols. But there are also some other well-known wireless protocols like Bluetooth. Anyway, consider that the name is called Bluetooth LE, meaning low energy. So it's not necessarily the Bluetooth you know that we have in our mouse or in our mobile phone. It's a Bluetooth which has a longer range. I read about it, and they said that on Bluetooth LE, it's possible to set up connections up to 100 meters in open space, or up to 30 meters in a building meaning through walls. And another protocol on which we focused in the last time is the so-called LoRa or LoRaWAN. LoRa, it's just to do not make confusion. What is LoRa? What is LoRaWAN? Is the same like I mentioned earlier about Modbus. So the RS485 is a hardware level, and Modbus it's a protocol. The same is with LoRa. LoRa is a hardware protocol, or a better comparison is like the MAC address. You know that, for instance, an Ethernet board has a MAC address, and on the MAC address is running the TCP IP protocol. The same is in LoRa. So LoRa is the physical layer. I made the comparison with the MAC address. And the TCP IP is a protocol related to LoRaWAN. Yeah. Both Bluetooth and LoRaWAN has the advantage to be first low power, and low power means that it's possible to work on batteries, which is, let's say, important, and let's say long range. Here, LoRaWAN is much better than Bluetooth. Because, let's say, in open space outside and in direct, so no obstacles between receiver and emitter, can be up to 15 kilometers or even more. And inside the building, I read about 100 meters or even more. Okay, we already made some tests with LoRa propagation, and let's say looks that has a good propagation especially in buildings. So we tested, for instance, here in our office, and yeah, going outside, we can set up good connections from the limit of our property to the gateways. Okay, so somehow just have this basic information regarding how communicate or how exchange data between the edge computer and the sensors. Okay, so what is the edge computer? The edge computer, as I said, should have first the task to forward the data received from the sensors. So this is a basic task. And coming to LoRa, this kind of edge computer is called gateway. So when we speak about a gateway, you should normally understand that we refer to a device belonging to LoRa. But edge computer can do more, and this more means that edge computers can even process the local data. Finally, the actual automation systems have this kind of architecture. There is an edge computer, and you can consider also the PLC to be an edge computer. So connect with sensors and actuator, and accordingly to these values, can take decisions. Yeah. But the difference between an edge computer and a PLC, what I told you earlier, is that normally the edge computer is also connected to a platform, or let's say to an application server somewhere outside the building where it's placed. And very often this outside means cloud. Yeah, but okay, is not mandatory, but normally it's to cloud. And anyway, the trend is even still it's possible to have a physical server in a company, but the trend is also to move everything to the cloud. Okay, so the edge computer is sending data to the cloud. Can be, and this happen in LoRa environment, that the data are not sending directly to the application server, but there is an interface between gateways and application server in LoRa called network server. Yeah, so the network server, it's an interface. It's a computer, of course, which is running a special software. And as I said, connect is the interface between sensors and application server. The application being, of course, a server which offers to its clients a view on the sensor's value, or allow the clients to send commands to actuators. This kind of software, or this kind of visual interface has a name of dashboard. Yeah, so dashboard, it's a name. And of course, clients in this moment are supposed to be devices which run a browser. Yeah, so using only a browser, you are able to see, let's say, what happens with the sensors. Yeah, so this is the application server. So it's offering dashboards to its clients. It's important to use browser because in this way you let a lot of options. So the platform can be accessed from a PC, a laptop, a mobile phone, or a tablet. So the advantage is that the client is totally independent. In most cases, it's not necessary to install a client software on its device, but of course there are cases when this can be done for a better view. Yeah, so this is the application, is offering dashboards, and a dashboard, you will see later, it's composed from panels or widgets. Yeah, so a dashboard normally has few panels or widget, and of course can be more dashboards, can be one or more panels or widgets. Okay, so these are, let's say, the main parts of IoT architecture. What you should understand is that we discussed about task or about servers. You keep in mind, we discussed about the gateway or edge computer, we discussed about the network server, we discussed about the application server. Keep in mind that all these components can be separate, so that means can work on different machines, but it's possible to run on the same machine. Of course, with advantages and disadvantages. If you run everything on a single machine, of course, you have the advantage of cost. So you run everything into one machine. But of course, there are disadvantages, or let's say this kind of architecture can be used only in small systems. So wherever you have 50 sensors, up to 50, probably 100 sensors, this architecture can be worked fine. But in the moment we are speaking about hundreds of sensors or actuators, at that moment, of course, it's better to have different machine which can be in the same place or can be in cloud, and to make these tasks. Okay, so this is a general architecture. Of course, you can study by yourselves, looking at IoT, looking with Google on IoT architecture and so on. But for the moment, please let me take a break. Okay, I'm back. Now I will try to share my my screen. Now you can see my screen.
Yes, sir.
A Node-RED, yeah?
Yes.
Yes.
Okay. Okay. So as I told you, now I'm trying to introduce a solution involving connecting some LoRa sensors using a so-called network server. Some of you knows that we have in cloud this ChirpStack server. ChirpStack is the name of the network of a well-known network server, but there are some others network server providers like the ThinkStack, Helium, Actility with ThinkSpark, etc. We are using for McDonald's, but also for testing this network server, ChirpStack, because it's open source, so it's free, like Linux, for instance, and it's installed in one of our server in cloud. So you can see on the map that we have 3 gateways. So if you remember, the gateway is a device which is communicating directly with the sensors and forwards the values to the network server. So here there is the gateway from McDonald's in Bucharest. Green means that it's online. And we have two others too here in Polisea. So one is in our office, and the red one, it's one which was used for test, is installed by Arif, and it's red because now it's not in use. But the green one, is a sensor which is in our office in Polisea building. Yeah. So the gateway, as I said, is connecting with the sensors, which can be energy matters, temperature, and so on, and forward. So the gateway, and probably most of you already see some gateways we have in our lab. These gateways are sending the data to the network server. I don't go deeper to explain the function of the network server, but in few words, you should keep in mind that the transmission between sensors and the gateway is in an encrypted form. So in this way, somebody outside who can hack or intercept the data from these sensors, he can do it, of course, but the data are encrypted, so it's not possible to read the payloads, the content of the sensors. And this is one of the tasks of the network server. So the network server is able to decrypt the values from the sensor. To give you an example, assume that the temperature sensor is sending the value of 20 degrees. Yeah, so now the temperature in lab is 20 degrees. He will not send this 20 value to the gateway in an open format, but the data will be encrypted. And the network server is the one which decrypt the message, and it will send to the application server. Yeah, for instance, here we have some applications. This is, for instance, the one containing the sensors we have installed in McDonald's Bucharest. And you can see here the converter for measuring the water, the gas. This is a converter which read energy, power, etc. from the energy meters, and three temperature and humidity sensors. One in the kitchen, one outside, and one in the lobby. And of course, here you see when that sensor sent its last message. Of course, you see that there are sensors like energy, which sending data more often, every 5 minutes, for instance, or the temperature, which are sending every 15 minutes, or gas and water, which are sending every 6 hours. Yeah. Okay, so this is, as I said, the network server, which receive encrypt messages from the sensors and forward to an application server. And what is the application server? This is a computer running of course, a special software. I decided to use Node-RED. Node-RED is a programming language. We can call it a programming language, but as you see, it's very intuitive. In fact, you just connect these nodes. So every rectangle from my screen is called node, and every node has a special function. And as I said, using Node-RED, you can create a program, not being a programmer or a developer. Yeah. And you can consider Node-RED as a programming language for engineers or for hardware engineers. So for people who has not big skills in programming. Of course, you need to have some knowledge about programming and programming language, but let's say it's good to have it. But even if you haven't, it's quite easy to learn. Okay, so every node you may consider as a block of instructions. So behind this node there is a piece of software. Yeah, so a lot of lines in JavaScript. Probably you've heard about JavaScript and Node.js. These are high-level programming language, but Node-RED, as I said, it's also a programming language, but using pieces like in a puzzle. Yeah, so you can put together. Okay, so the first task we need is to collect the data from the network server. So if we want, and now I let you in advance the final point or the destination where we want to go. Yeah, this is, let's say, a dashboard where a customer can understand what is happened, for instance, with the temperature. Yeah. So, but to reach this point, first we have to collect the data, and this is, let's say, the magic node which can do it. For instance, I'm using here a so-called MQTT in Node. You should understand that between if you when I discuss about architecture, I told you network server, application server, gateway, edge computer, and so on. But to exchange data between these components is using a protocol. And in the moment when we go outside the company, when we go through internet, there are some protocols, especially for this kind of exchanging data. The most known protocol is HTTP. Yeah? For instance, all of you are using the HTTP in the moment when you open the browser and put there, I don't know, Polysea.ro or Google.ro. Yeah, at that moment you are a client, so your computer, your browser, it's a client who is exchanging data with a web server, and this exchange data is made using the HTTP protocol. What I want to tell you is that HTTP protocol can be used not only for web servers or for browser. It's so flexible that HTTP can be used even to exchange data, for instance, between a network server and an application server. But HTTP initially, when was designed, it was a protocol, as I said, for exchanging data between client and web servers. To exchange data between a component of an IoT architecture, of course, HTTP can be used, but the main disadvantage of HTTP is that it needs a lot of data. Yeah, for instance, look here. Yeah, in my browser. Yeah, so I in order to exchange an information with a computer, I have to write a long string, which of course means longer payload, consume of energy, and so on. For this reason, software engineers developed another kind of protocols, which are not only shorter, but also more appropriate to IoT, where to have shorter message, it's a must. And such kind of protocol is the MQTT. Yeah. So when you heard about MQTT, think that is something like HTTP, but who fit better to the needs and the specific of IoT. And now I can give you this example where this MQTT node is able to connect to our ChirpStack server. Yeah, this is our ChirpStack. You see that its address is LoRa Polycea Rho. Yeah. So here we specify that this node should get the information from the network server, which is this address. And also here I specify the so-called topic. So it's the place where from the information is taken. I don't know. Yeah, if it's good to explain you a little bit how is the MQTT architecture, or to study by yourself. Please study by yourself, and if there is something which you don't understand, please ask me, or probably in future we can arrange another conference to explain you also how MQTT is working. Okay, so just consider that this is a topic. It's like a channel. Yeah, if you sing to a radio station, yeah, a radio station delivers news, music, and I don't know, advertising, etc. So music, news, advertising, please consider as a channel. You, as a guy who is listening to a radio station, you can program your radio that every time when the music on the music channel there is a song, to be informed and start to listen. Yeah, so the topic you may consider as a channel where you are where you have a subscription. Yeah, so you subscribe to that channel. Of course, to Arif and probably to Dan Dorian, I may explain better the syntax of this topic. Just as an information, what is important here is this 6. 6 is the application number. If I go here to ChirpStack, yeah, and go to application on McDonald's, you see that the application number of Bucharest Cascadelor, it's 6. So with this information, I told the network server, okay, please give me all events which are uplinks. So uplink means that the sensor is sending information. Downlink is when the sensor receives information. So please send me all uplink messages sent on application 6 by all devices. Yeah, so this plus means all devices. I can put here, of course, for instance, the name of Modbus Dragino, meaning that I want to get only the values from this Modbus Dragino. But here I decided to listen to all sensors from this application. So from Bucharest, McDonald's Bucharest. Also, I want to output, so receive, so this node receives the data from the network server and send a so-called JSON object. JSON, it's a format like Excel. Yeah, so you can think that in Excel, for instance, probably you've heard about CSV format, comma, separate values. JSON is something similar, and here you have example of JSON. So JSON, it's a text, yes. So like you type on your keyboard, a text using this, I don't know what is the name in English. In Romanian, we call accolade. This is kind of parenthesis, yeah? And the content is name of the value, and the value itself, yeah? So that means this node received from the network server values, energy frigorifică, energy încălzire, and so on, and the value. Yeah, so in this case, we know that the total energy is 92,890 kilowatts. By the way, I don't know if I have here. Yeah, let me show you also the interface for McDonald's. Oh no. Just a moment. Yeah, looks I didn't save here. Normally I have a password to connect directly. Now will be longer, but just a moment. McDonald's. Yeah, so this is the dashboard which a customer can see. Yeah, and just to show you, we have here the index of the energy counter, and you see the value is 19,923. It's like here, but of course here it's an older message. Probably if we are looking to the last one, we can get here the yeah, this 92,923, which is the same value as here. Yeah, so this node extract the value from the network server. Here I separate because I told you that this node is listened to all devices, to all sensors. And in my example, I extract only Modbus Dragino and temperature outside. Yeah, if I look here, yeah, I want only this device and only this device. Yes, the other I ignore. And what I'm doing with this value, I inject this data in a database. Yeah, so all these values should be stored in a database. Yeah, they're a so-called InfluxDB database, which is a special database where besides the values is recorded also a timestamp. Timestamp meaning the exactly moment when the device was sending that data. For instance, on 18 October 2021 at 10 and 10 seconds, 63 seconds, and so on. Between this extract the JSON and inject to the database, I put this function which convert from string to number. Yeah, because you see this kind of values can be number or can be string. You know, in Excel, the same number, let's say 223, you can have it as text or you can have it as a value. And because our InfluxDB is expecting here numbers, I should make a conversion. To give you an example, yeah, for yeah, also here for temperature, I convert from string to number. Yeah, I don't go deeply to explain you the difference, but please consider for the moment as it is. Okay, so extract data, change or convert values and so on, and inject in the database, which is the InfluxDB. You can see here I have this Linux machine. This is our application server. And on this machine is running Node-RED. is running InfluxDB, so the database, and also is running what you will see later, the InfluxDB. Here I have a screen with the influx. Yeah, here you can see that I specify what database I want to use. The name I used initially was weather, and for instance, I can see all the values sent by the devices and recorded in the database. Yeah, you see this is on 17th, so yesterday at 6:50 the temperature was 10.5, and this device is sending data from 15 to 15 minutes. So 6:50, 7:05, 7:20, and so on. Yeah. So all these data were injected, were stored in the database using Node. Of course, if I want to see the values for energy, yeah, I can see here this this value with the timestamp. Yeah, and you see that each column has a name of the value, and in the column it's a real value. Yeah. So to explain you a little bit more about database. So a database, it's a collection of data. For instance, a phone book. Yeah? A phone book, it's a data collection or a database. In a database, I can have tables. Yeah. So you can consider, for instance, that I want to store the phone book, but also I want to store a table with all employees in Polycea. Yeah. So a database, it's a collection of tables. For Influx, this a table is called measurement. Yeah. So here I give you example. So the database is weather, but I give you example of two tables: energy, yeah, energy MCD, or temperature. And if I go back to these nodes, for instance, you can see that the name of the database is weather, but the table, or as I said, or is called measurement. So I mentioned here that the value, yeah, the value injected by this function, so this JSON, yeah, is going to weather, the database, yeah. And if you can see here, this is a server. So this is the Influx server, which run locally on port 8086. The database is weather, and the measurement is energy MCD. If I'm looking to this one, you see that the measurement is different. It's temperature exterior. Yeah. So I show you here, yeah, how it's looking exterior temperature, how it's looking energy. Yeah. this is values for energy. By the way, here you see that the data for energy is injected every 5 minutes. 43, 48, 53, 58, and so on. Okay, so I succeeded to inject and to store all the data. That means that now if I stop the server and restart, all values are kept in the database and are not lost. Okay, but what should I do with this data? I'm using this data to generate a chart, for instance. And now this is a place where we discuss about the third component, which is the application server, or the last part of the application server, which is Grafana. Yeah? So Grafana has this ability to that on a dashboard. This is a dashboard with 3 panels or 3 widgets, where I can see, you see the evolution of power. Here I use power. Here is the temperature. In order to be prepared to display these charts, the first step you need to do in Grafana is to specify a source. Yeah, so where from you get the data. And this one, in our case, it's the InfluxDB. So it's the server for InfluxDB. But I need to take a break because I have a visitor, and probably in 20 minutes we'll be back. Hello, can you hear me?
Yes.
Arif?
Suntem toți aici.
Okay, perfect. So just for few minutes more. Okay, so I told you that in Grafana, the first step is to define the data source. So where from this application takes the data? It's quite simple. Yeah, so if you go here to configuration, you can leave all default values. The only things which you should input, it's the URL or of the InfluxDB server. In our case, because both Grafana and Influx are running on the same machine, we can use localhost, and the port it's 86. Anyway, these ports are default values. So if you read the documentation, you will find the values. For the moment, I didn't pay any attention to security, meaning using users and password and so on. So all access is open. Yeah, so it's open to anonymous. Also in Node-RED, you see that in MQTT there is defined no user, no password. But of course, in real implementation, we should define user and password for each application. So coming back here, also the InfluxDB, it's open. So if you know the address, you can get the value. Database. I remember I remind you that weather is the name of the database. no user, no password, because as I said, the access is open for anonymous, so it's not necessary to define user and password. Yeah, so this is everything. And in regarding the data source, and of course now this is the main window of Grafana. As you can
check? How can you check is connected correctly to the
it's the moment when you place, so when you go to settings, when you place this save and test, if it's working, it will give you success or something like this. Otherwise, because initially I had some errors, I was looking what kind of errors, and finally I succeeded to fix it. You can, for instance, also use explore if you really want to test something. So this is a query. Yeah, so query in databases means the request. Yeah, so we are speaking about the so-called SQL databases. I don't want to give you more details, but SQL databases means that the client do not need to have the database in his storage and look for a record, run a program to look for the record, but instead the dialogue between client and server is through questions or requests or queries. Yeah, and this is a kind of query. Just to give you an example, where from you want. I want from energy MCD. This is a measurement. Remember, so the database it's like a library. Yeah, and now I'm looking for a writer. Yeah, energy field. What I am interested. I want to see energy rooftop. Yeah, and you can see here that being everything okay, I've got the values. Yeah, so this is a proof that the database is connected and you have accesses. So this is somehow another way to test you have access. Of course, I can here change, for instance, a dot. Yeah, and I see, yeah, you see here the values are different, are over 92,903, and from 5 minutes to 5 minutes, yeah, you see it's 1023, 1028. Yeah, so these are. So I press, or you can press run query, and you see the values. Yeah. Okay. Okay, and manage. So once you define the data source, now you should create dashboards. The dashboard can be saved in folders. By default, there is a folder called General, and here I create two dashboard. One is this, what I already show you. It's very easy and intuitive. You see, you can move the panels very easy. You can change the size of the panel, and it's quite easy. And of course, you can add new panel. Yeah, so if I press add panel, I choose add an empty panel, and here you should define the query. Yeah, so I will take energy MCD, and I select here. I don't know why sometimes here I have to click to the right. I will take this value. Yeah. So I define, and here it's what kind of panel you choose. So I show you time series and how is a gauge. And of course, here there are a lot of things you can change, like colors, what value do you want? This is the last value, or you can select, I don't know, the minimum value, or total or count. Count, I suppose, it's a number of updates. And yeah, so you have a lot of options, including delta. This is an important value. The delta, it's every time the difference between current and previous value. This is very important, by the way, for energy meters. You know that the energy meter or water meter or mainly all meters are only increasing. So you can start from 0 and the value increase as you consume. But in fact, for instance, for energy, you want to see how much is a consume from beginning of the month, or on last week, or so on. Yeah, so that's why you are using delta. So the difference between the last value and the value at the beginning of the interval you are interested. And for instance, I can see here, I don't know if it is using. Yeah, looks at for time series, only for gauge, I can select the calculation. Yeah, calculation is a name. Let me check if in time series I have calculation. Looks that I haven't, but yeah, probably this can be done in. I didn't check all of this, like bar chart, pie chart, table. Yeah, by the way, yeah, table, you see here that we have values, and yeah, how the value is increased, and all this interval probably are here from minute to minute, or 15 from 15 seconds. Okay. It's yeah, so in this way, let me finish with this, let it gauge, and I can apply, and you see now I have this, and for instance I can change the title, or instant, which I can see instant power. Yeah. Okay. So probably for most of you, all I show you it's very new. So I don't expect you to have many questions, but yeah, please free to ask. So the idea is that wherever customers are asking for an application to monitor something, we have two options. We have the option to offer them a subscription, meaning that we are using cloud, and for cloud is necessary that they will pay a monthly fee, or we can offer a complete application, which means a computer which will include an edge computer, which can do everything. And of course, at that moment, the client will access via internet these dashboards. Yeah. So of course, every solution has advantages and disadvantages. This one, of course, this local one, one of the biggest problem is that if something is happen with the computer, he risks that all his data is lost. So for this reason, they need that from time to time to save the database. By the way, in database, one important topic is the so-called retention and retention policy. You realize that this database, the database is increasing, and could be that after a few months, if there are a lot of values, even if each value doesn't contain a lot of information, but multiply by number of updates per day with number of devices, you can easily reach gigabytes of information. That's why by retention, you can set up a parameter in the database by telling the database to keep, let's say, only data not older than 1 year, for instance. So if you do this, that means that automatically the database will delete and make room all information which is older than 1 year, by the way. Of course, another useful function with database is that you can define, as I said, delete all the data, but also you can let the data to keep, for instance, in our case, the energy not from 5 to 5 minutes, but to keep all the data which is older than 3 months, to keep data only from 30 to 30 minutes, you see? So it's somehow an optimization. So instead, as I said, to keep the data for 1 year by 5 minutes, you tell to keep only by 30 minutes. That means that instead into 1 hour, instead to have 12 values corresponding to 5 minutes update, to keep only 2 every 30 minutes. Yeah, and sometimes for database, for client, this is okay because nobody will be interested to know how much was the power consumed in 5 minutes in November last year. Probably he will be interested in to know how much energy I used for 1 day. Yeah, to give you an example. Of course, if the customer want to keep all information, he can save. Yeah, and by the way, also Grafana offer such option. Let me check here, I suppose. Data. Yeah, so I go to data and I can download in CSV format. Yeah, so I can save this in a CSV format. You see, it's in Excel format, and I see here all anyway, I have to convert. I have to convert from CSV in Excel, but you can see here's a timestamp and value. Yeah, I didn't convert, but there are options to convert to Excel format. Yeah, even in Excel you can do it. Yeah. So if you have questions, and by the way, now I have to save the dashboard because you are working now in browser. So if you didn't save the dashboard, all what you do is lost. Yeah, to show you, if I go here, I have a message, an attention message telling me that I have to save. Yeah, so okay, save. Yeah, and now if I open again, I have the latest version of the dashboard. Okay. If you have questions, please ask.
No, sir.